when any number is written in decimal number system. For example, let's have some number 4791 point say 325 etc. Some number. It is considered of integer plus fraction both part. Then every digit has its place value or weight. Then how to find out the weight is? Weight of this is 10 raised to 0 because this is decimal number system. Weight of this is 10 raised to 1. Weight of this is 10 raised to 2, 10 raised to 3, and here 10 raised to minus 1, 10 raised to minus 2, 10 raised to minus 3. This way. So this number in the expanded form is written as 4 into 10 raised to 3 plus 7 into 10 raised to 2 plus 9 into 10 raised to 1 plus 1 into 10 raised to 0 plus 3 into 10 raised to minus 1 plus 2 into 10 raised to minus 2 plus 5 into 10 raised to minus 3. So this number is now 4000 plus 700 plus 90 plus 1 plus 0.3 plus 0.02 plus 0.005. When all of them are added, we get this one. So for every digit, there is a separate value, and this is called as a weighted code because every digit has a separate weight or separate place value. Exactly similar concept is for octal numbers also. So if we want to convert any number system into decimal, then we have to use this expansion method in that number system. So let's see for octal. So in case of octal, the base is 8. So let's consider any octal number. Let the number be say 524. Suppose this is a octal number. When this is octal number, this will have the place value or weight as 8 raised to 0 because octal means base is 8. 8 raised to 0, 8 raised to 1, 8 raised to 2. So this number will be expanded in the form as 5 into 8 raised to 2 plus 2 into 8 raised to 1 plus 4 into 8 raised to 0. In this way, the numbers will be expanded. Now when the number is expanded, we have to calculate. So 5 into 8 raised to 2, I am using the calculator now. 8 raised to 2 is 64. So 5 into 64 plus 16 plus 8 raised to 0 is 1. So this is nothing but 4. So what we get is 64 into 5, 320. 320 plus 16 plus 4 plus 16 plus 4 equal to 340. So 340 is the number in decimal. So what we get is 524 octal is equivalent to 340 decimal. This is the way of conversion. So every digit is multiplied by its weight. For the integers, the weights are 8 raised to 0, 8 raised to 1, 8 raised to 2. For fractionals, they will be 8 raised to minus 1, 8 raised to minus 2, 8 raised to minus 3. So let's have such examples, few more examples for octal to decimal conversion. So octal to decimal conversion. So let's have one more example. Suppose 375. So 375 is octal number. So 375 means 8 raised to 0, 8 raised to 1, 8 raised to 2 will be the weights. So 3 into 8 raised to 2 plus 7 into 8 raised to 1 plus 5 into 8 raised to 0. So this we get as 8 raised to 2 is 64. 64 into 3, that is equal to 192, plus 56 plus 5 plus 56 plus 5. That gives us 253 in decimal. So this is octal to decimal conversion. Look at the numbers. The number in octal is bigger than the number in decimal. So this is for the integer part. If the number is in the, suppose, fractional part, let's have one more example. Let's take the number, for example, 25.64 in octal. So here the weight is 8 raised to 1, 8 raised to 0, 8 raised to minus 1, 8 raised to minus 2. So let's expand this. 2 into 8 raised to 1 plus 5 into 8 raised to 0 plus 6 into 8 raised to minus 1 plus 4 into 8 raised to minus 2. So this will be 16 plus 5 plus 6 divided by 8 plus 4 divided by 8 into 8 squared. So let's calculate this using a calculator. So we get 16 plus 5, that is 21, plus 6 divided by 8 equal to 0.75 plus 4 divided by 64 equal to 0.0625 plus 0.75 plus 21 equal to, so the number becomes 21.8125 in decimal. So 25.64 octal becomes 21.8124 in decimal form. So this is the conversion. Let us have one more example. Only fractional part, for example. Suppose let's take 0.48 octal number. 0.48 octal number. Then 0.48 octal will be expanded to 4 into 8 raised to minus 1 plus 8 into 8 raised to minus 2. So this will be 4 by 8 plus 8 by 64. So let's calculate this. 4 divided by 8, it's 0.5 plus 8, this is nothing but 1 by 8 equal to 0.125. So it comes out to be 0.625 in decimal. So 0.48 octal comes out to be 0.625 in decimal. Now let's convert. This is the method for octal to decimal. Exactly similar method will be for hexadecimal to decimal. In hexadecimal, the base is 16. The base is 16. So whatever are the number of digits, their weights are, suppose decimal point is here, then 16 raised to 0, 16 raised to 1, 16 raised to 2 on this side, 16 raised to minus 1, 16 raised to minus 2 if this is a decimal point this way. So let's have example. Let's have 3c, some number in hex. 3c. So 3c means after 3c there is a dot. So the expanded form will be c means its weight is 16 raised to 0, and here the weight will be 16 raised to 1. So plus 1. So 0. So 3 into 16 raised to 1 plus c into 16 raised to 0. Now what is c? C is nothing but 12. C is 12. So what we get is 3 into 16 plus 12. So let's calculate this using the calculator. This is 48 plus 12. So it comes out to be 60. 60 in decimal. So 3c in hex, 3c hex is equal to 16 decimal. Let's have one more example. Let's have another number. Suppose E5. E5 in hex. E5 in hex. We can have a bigger number also. Suppose 2E5 in hex. 2E5 in hex. So weight of this will be 16 raised to 0. Weight of this is 16 raised to 1. 16 raised to 2. So let's expand it. 2 into 16 raised to 2. E into 16 raised to 1 plus 5 into 16 raised to 0. So 2 into 256 plus E. What is E? E is 14. 14 into 16 plus 5. So let's calculate this using the calculator. I'm using mobile's calculator. 2 into 256, that is 512 plus 14 into 16, 224 plus 5. So add this plus 5 plus 512. So the number comes out to be 741. 741 in decimal. So 2E5 in hex is equivalent to 741 in decimal. So this is the conversion from hexadecimal to decimal. Let's have one more example with maybe decimal point. So let us take one hex number as suppose 7B. I am purposely taking A, B, C, D, F dot suppose A2. So decimal point is here. So expand this. 16 is to 0, 16 is to 1. So 7 into 16 is to 1 plus B into 16 is to 0 plus A into 16 is to minus 1 because it is on the decimal point, after decimal point, plus 2 into 16 raised to minus 2. So what we get here is 7 into 16, this number, plus B. A is 10, B is 11. 11 into 16. A is 10. 11 into 16 raised to 0 is 1. A is 10 into 1 upon 16 because 16 is to minus 1 plus 2 divided by 16 into 16, that is 256 because 16 is to 2. Now let's calculate all the values and then add them. So 7 into 16 is equal to 112, 112 plus 11 plus 10 divided by 16, 10 divided by 16, that is 0.625 plus 2 divided by 256, that is 0.0078125. Now add all of them. Plus 0.625 plus 11 plus 112 is equal to. So the answer is 123 123.632815 in decimal for 7D.82 in hex. So here is also decimal point, here is also decimal. So in this way, with fraction, you can convert it. Suppose your number is only fractional number. Let's have one more example here. That let's take the number say 0 D8, suppose 0 D8 hex, then convert it. So after decimal point, so D into 16 raised to minus 1 plus 8 into 16 raised to minus 2. Now what is D? D is 13. 13 divided by 16 plus 8 divided by 256, because 16 into 16 is 256. Now let's calculate using calculator. 13 divided by 16 is equal to 0.8125 plus 8 divided by 256. 8 divided by 256 is 0.3125. Now add both of them plus 0.8125 is equal to. So the number comes out to be 0.84375 in decimal. So this hex number is equivalent to this decimal. So this is the conversion of any hexadecimal number to decimal number. Exactly similar procedure is for binary also. In case of binary, now we want to convert binary to decimal. In octal the base was 8. In hex the base was 16. In binary the base is 2. Base is 2. So the weights are 2 raised to 0, 2 raised to 1, 2 raised to 2 and so on. So let's take any number. So let's take 10, 11, 00, suppose any number. So this is a 6 digit. So weight of this is 2 raised to 0. Weight of this is 2 raised to 1. Weight of this 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5. This way the weights. So how the expansion will be? 0, 1, 2, 3, 4, 5. So expansion will be, you can start from this also or you can start from this also. So 1 into 2 raised to 5 plus 0 into 2 raised to 4 plus 1 into 2 raised to 3. This 1 into 2 raised to 5. This 0 into 2 raised to 4. This 1 into 2 raised to 3. This into 2 raised to 2 plus 1 into 2 raised to 2 plus 0 into 2 raised to 1 plus 0 into 2 raised to 0. Now in this, if there are zeros, they just cut the terms because the multiplication will be 0. 2 raised to 5 is 32. You must remember 2 raised to 1, 2, 2 raised to 2, 4, 2 raised to 3, 8, 2 raised to 4, 16, 2 raised to 5, 32, 2 raised to 6, 64. All of these you should remember. 2 raised to 7, 128, 2 raised to 8, 256. You should remember all. Plus 2 raised to 3 is 8, 2 raised to 2 is 4. So add all of them. So this is 32 plus 8 is 40, 40 plus 4 is 44 in decimal. So what we get is this number in binary is equal to 44 in decimal. So in this way the binary to decimal conversion is there. We'll have 1-2 more examples for this. So let us have one more simple example. Suppose 1 0 1 0 1. So let's expand this. Start from this. Start from this and start this way. So this one is 1 into 2 raised to 0 plus. Now this 0. 0 into 2 raised to 1. Now this one plus 1 into 2 raised to 2. Go on increasing the weight. This 0. 0 into 2 raised to 3 plus this 1. 1 into 2 raised to 4. Now expand. Wherever 0 terms are there, just scratch them. 2 raised to 4 is 16. 2 raised to 2 is 4. 2 raised to 0 is 1. So 1 is here. So 21. So 10101 binary is equal to 21 decimal. So this is for the integer part. If there are fractional parts, then the weights are 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3. So let's have the example of that also. So let's have this number 1 0 1 1 0 0 0.011, very big number, just for example. Now the weights. This is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5. Then decimal point is decimal point. So here 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3. Now expand this. 1 into 2 raised to 5 for this one plus 0 into 2 raised to 4 plus 1 into 2 raised to 3 plus 1 into 2 raised to 2 plus 0 into 2 raised to 1 plus 0 into 2 raised to 0 plus 0 into 2 raised to minus 1 plus 1 into 2 raised to minus 2 plus one more 1 into 2 raised to minus 3. This is the expansion. Now wherever 0 terms are there, just delete the 0 terms. This and this. Only one term. 1 into 2 raised to 5, that is 2 raised to 5 is 32, plus 2 raised to 3, that is 8, plus 2 raised to 2, that is 4, plus, now these two terms, these three terms are cancelled, and directly this term 1 divided by 2 raised to minus 2 means 1 upon 2 raised to 2, that is 1 by 4, plus 1 divided by 2 raised to 3, that is 1 by 8. Now solve this. 32 plus 8 is 40. 40 plus 4 is 44. 44 is the integer part. Plus 1/4. 1/4 is, we know, 0.25. 1 by 8 also we know 1. So add all of them. Adds 44 point. Then the 2 plus 1 is 3, 7 and 8. This will be the answer. 378. 8, 7. Yes, this is the answer. So this will be the expansion. Let's have one more example if you want of this type. If you have only the fractional part, still you can expand this. Suppose the number is 0.101, only fractional part. So let's expand this as this one into 2 raised to minus 1 plus this 0 into 2 raised to minus 2 plus this one into 2 raised to minus 3. So let's cancel the 0 term. So 1 by 2 plus 1 by 8. So 1 by 2 is 0.5. 1 by 8 is 0.125. 1 by 8 is 1 divided by 8 is 0.125. So add both of them. So what we get is 0.625 in decimal. So 0.101 in binary is equal to 0.625 in decimal. This is only for fractional part. Let's have one more example with integer and fractional. So take 1 0, suppose 1 1 0 0 1 1, suppose this is the number 0.11. Let's take this. So expand this. So this is 0, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, minus 1, minus 2. So let's expand. 1 into 2 raised to 5 plus 1 into 2 raised to 4. Let's have a smaller number, suppose. Let's have this much number. 1001. Why 20? So 1 into 2 raised to 4 plus 0 into 2 raised to 3 plus 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 0 into 2 raised to 0 plus 1 into 2 raised to minus 1 plus 1 into 2 raised to minus 2. So cancel the 0 terms, this and this. So this is 16 2, cancel this, this 0 into, sorry, 1, this is 1 into 2 raised to 0, 1 into 2 raised to minus 1. So this is plus 1, 1 into 2 raised to minus 1 plus 1 by 2 plus 1 by 4. So 16 plus 2 is 18 plus 1 is 19. 19 plus 1 half is 0.5. 1/4 is 0.25, that we know. So the number becomes 19. Point. Add these two. 5 plus 2 is 7. 5. This is in decimal, and this number in binary is equivalent to this is in decimal. So in this way, any number system to decimal number system, the conversion is done.